Have you ever looked up at the night sky and wondered, where are all the aliens? If the universe is so vast, with billions of stars and even more planets, why haven't we found any signs of extraterrestrial life? This is the question at the heart of one of the greatest mysteries in science, the Fermi Paradox. In the early 1950s, a question arose during a conversation between physicist Enrico Fermi and his colleagues, who were discussing the likelihood of intelligent extraterrestrial civilizations. Fermi famously asked, "Where is everybody?" Now, nearly 70 years later, this question still echoes in the scientific community, as researchers try to solve what's known as the Fermi Paradox. Fermi's paradox is simple, yet profound. Given the vastness of the universe and the high probability of habitable planets, why have we not yet detected any signals or evidence of extraterrestrial life? The paradox is based on two key assumptions. The universe is incredibly old, billions of years older than Earth. There are billions of planets that could host life. These two assumptions lead to a glaring contradiction. With such a high probability of extraterrestrial civilizations existing, the question remains, why haven't we found them? To understand the paradox, we need to explore a few important concepts. Let's start with the Drake equation. Developed by astronomer Frank Drake in 1961, the equation attempts to estimate the number of advanced civilizations in our galaxy that might be capable of communication. The equation takes into account factors like the rate of star formation, the percentage of stars with planets, the number of planets that could potentially support life, and the likelihood of those planets developing intelligent life. Using this equation, scientists have concluded that there could be thousands, or even millions, of civilizations in the Milky Way alone. Yet, despite these odds, we have detected no undeniable evidence of alien civilizations. This is where the paradox deepens. We've been sending out signals into space for decades, using radio waves, laser beams, and even space probes like Voyager 1 and 2, carrying messages in the form of the Golden Record, a collection of sounds and images meant to represent humanity. If intelligent extraterrestrials are out there, why haven't they responded? Could we be missing their signals, or are they just not there to begin with? There are several possible explanations for the Fermi paradox. Let's break them down. Rare Earth hypothesis. One explanation is the rare Earth hypothesis, which posits that Earth might be an incredibly rare planet, with conditions perfectly suited for life. The combination of factors such as the right distance from the Sun, the presence of a large moon, a magnetic field, and plate tectonics could be so unique that life may only arise in a very small fraction of planets. This would mean that even though there are billions of planets, only a few may have the precise conditions needed for life to flourish. Life on other planets might be rare, or even non-existent. The Great Filter. Another possibility is the Great Filter hypothesis. This theory suggests that while intelligent life might be common in the universe, there could be a critical step, often referred to as the Great Filter, in the development of life that is extremely difficult to overcome. This filter could be the jump from single-celled organisms to multicellular organisms, or it could be the leap to advanced technology capable of interstellar communication. If this filter exists, then most civilizations never make it past this point. If the Great Filter is ahead of us, it could mean that humanity is on the brink of an existential challenge that most civilizations never survive. Alternatively, if the filter is behind us, it suggests that we may have already passed the most difficult hurdles in the development of intelligent life. Self-destruction and technological risks. Another theory is that intelligent civilizations tend to destroy themselves before they can reach the level of interstellar communication. Nuclear war, climate change, or artificial intelligence gone wrong could all lead to the downfall of advanced societies. This could explain why we haven't detected any signals. By the time a civilization becomes technologically advanced enough to communicate across vast distances, it might have already wiped itself out. If this is the case, then we might be one of the few, or perhaps the only, civilizations that has managed to avoid such fate, at least for now. They are out there, but we can't detect them. It's also possible that extraterrestrial civilizations are out there, but we simply can't detect their signals. They might be using communication methods or technologies that are far beyond our current understanding. For example, they could be using quantum communication or neutrino signals, technologies that are still theoretical or in their infancy for us. We may be looking for the wrong kinds of signals or frequencies. In other words, aliens might be trying to communicate, but we're just not equipped to hear them yet. They're too distant or non-expansionist. Another explanation could be that extraterrestrial civilizations are simply too far away, or they may choose not to expand beyond their home planet. Civilizations could be content with their own solar systems, avoiding interstellar travel and keeping their existence a secret. This idea also aligns with the zoo hypothesis, which suggests that advanced aliens are deliberately avoiding contact with us, much like humans might avoid disturbing a zoo animal. Perhaps the aliens are out there, watching us, but choosing not to interfere with our development. The Fermi Paradox presents us with an enigma that might never be solved. But in exploring this mystery, we gain a deeper understanding of our place in the cosmos. Whether we are alone in the universe or not, the search for extraterrestrial life continues to inspire us to look up at the stars and dream of what lies beyond. As we continue our exploration of the universe, the Fermi Paradox will remain a central question. And who knows? One day, the answer might just be out there waiting to be discovered.